So great, let's get started, folks. So in this session, we are going to talk about the new features that is there in Gen 2, something called as federation, something called as high availability. How do I run Hadoop in different modes? There are 3 modes of Hadoop deployment, and then implement the basic Hadoop terminal commands. I'll be working on that. I'll be demoing it to you. You will have to do it at your own level. Look at the various configuration files. How do I implement a passwordless SSH? Analysis of a Mapreduce, dump, and what are the different loading techniques. This is what is the plan of action for today. So like I had requested all of you, I hope you have gone through chapter number 1 and 3 of the definitive guide. So chapter number 1 and 3, what was needed? So let's get moving. So if you look at the various daemons that Hadoop has, last time we had seen it, what all are the core components of Hadoop? You have got the processing component that is called as yarn, and the storage component that is called as HDFS. HDFS will have NameNode and data nodes, and your processing component will have resource manager and node manager. So if we had seen last time, master components, there are 3 masters that we have in our HDFS. So you will have something called as NameNode. There is an active passive NameNode, then there is a secondary NameNode, and then in our yarn there is a resource manager. All 3 of them are there as masters. So when I talk about masters in your Hadoop, it typically consists of the NameNode. NameNode will have 2, it will have an active and it will have a passive master, and then also we will talk about the resource manager. Hey, before that there is also something called as a secondary NameNode, which is only for checkpointing. It is an optional thing. It was there in Gen 1 architecture and they have simply continued on with Gen 2 the same way. And you also have got something called as resource manager. Let me do a word wrap. And when we talk about slaves are typically on slave machines, you will have the data node plus your node manager working. So these are all the different daemons that we have that is running. Cool. So let's move on. Let me minimize all of the other things. So when you start off with your system, you will have, these are the core components that we have in Hadoop. Then we saw what is HDFS architecture last time. You know what is HDFS, what is the difference between Hadoop and traditional systems. And when we talk about secondary NameNode, we had covered. Perfect. So let's move on. We will talk about active, passive, etc. So hey, here comes Annie. She just want to be sure that you guys know whatever has been done till now. So let's go ahead and look at her questions. So the default replication, if I don't say, so the default replication is 3. Okay, so let me go down to the next slide. So there you see, hey, this is a typo. It should have been D. 3 is fine. No, it actually should have been D. So if it means that if you move a file to your HDFS, then 3 copies of the default would be done. So last time when I had given you a architectural diagram of your file write, we had mentioned about 3, right friends? So it is actually 3. So there are 3 copies of every block that will be there on different nodes. So what's the answer to this? Every slave node have got 2 daemons running on them, that is data node and the node manager. If we look at a multi-node cluster, the answer is true. I just mentioned that in the diagram some time back, so good. So data node service is for your HDFS component and node manager is for the processing component. Now let's go down to the next question. A block is replicated in 4 nodes. That means for this particular file, they have set that the replication is going to be 4. If any of the 3 nodes fail, can a client still read the data? The answer is true. The client can still read the data. So who is responsible to ensure that the nodes will automatically get the replication? It is a framework. So the framework will ensure that if you set that the replication factor is 4 and if 3 nodes on which the data is there, it goes down, the framework will automatically start replicating it from the one block that is there, so that in the case of a worst case scenario, you don't lose your data. So the main purpose of replication is to ensure that it is redundant. Cool. So the answer to this thing is L. So let me look at Praveen's question. He said, you need to move a file called as weblogs into HDFS. When you try to copy the file, you can't. You know that you have got ample space on your data nodes. What action should you take to retrieve this situation and store more files in HDFS? Very good question. So guys, what do you think is the answer? Is this from session 1 or session 2? It is from session 2. It's a quiz session 1. Okay, so then the basics of this you should know. So they said increase the block size on all the current files. Second is increase the block size on your remaining files, decrease the block size on your remaining files, or a lot of increase and decrease. So what do you think is the right answer and why? So he has taken up that question. He feels that this is the case. So why can't you put more files into the data nodes? The reason is because the name node is full, right? The name node does not have enough memory to store the data. So that is the reason why there is, although you have got ample space on your data nodes. So what do you think should be the answer for this? Exactly. So the right answer is because metadata is not there to store. That's correct. So what is the way to resolve this? What is the way how you can do that? You should ensure that the metadata is less, right? That way you will have more files stored. Make sense? One is add more RAM and replication, etc. You will see that. Let me just go ahead, guys. So see over here, if the name node does not have enough memory to store the metadata, okay, this is typically in Gen 1. So in Gen 2, that what you are learning, there is something called as federation. Federation technique will ensure that you will have enough name node. Second is you should increase your RAM on your machine, okay? And the third thing is what you could also do, if you can't increase, get in one more name node, and if you can't increase the RAM on your machines, okay, then what should we do is you should increase the block size in your machine. So take this example. If you have got one file of 100 MB, or let's say one file of 200 MB, in our systems, how many metadata pointers do we need? One file of 200 MB. You would need, assume replication as 3, you will have 6 pointers. Okay, so if I increase the block size to 250 MB, 256 MB, how many pointers do I need to have? I need to have 3 pointers, right? Because by default, the block size is 128 megs. Got it? So that is the trick over here. So first, try to increase the RAM. Okay. Second, you can have multiple name nodes to manage the file system by directories. That's correct. Hey, how did I get 6? There are 2 blocks, right? 200 divided by 2. This is the example that we have done, Nagesh. What's happening? If the replication factor is 3, every block will be copied 3 times. 200 MB will have 2 blocks, 2 into 3s are 6. Got it, Nagesh? Fantastic. So Krishna had a point. Name node can still be a bottleneck because its RAM capacity decides how many blocks can be stored, because the number of blocks is equal to the number of metadata stored in the RAM. That is correct, Krishna. That's why we have got something called as federation. We will see that right now. Okay? So let's move on. So this is what is the hardware configuration that you should have. This is what is a sample configuration from a actual production environment. So you can see over here, your active name node has got 64 gigs of RAM. It has got less hard disk, 1 terabyte. The processor is Xeon with 8 cores. It has got an Ethernet. Okay, and it has got a redundant power supply. Then you have got a passive. The passive is also called as a standby name node, because at one point of time you can have only one name node in active state. That will also have the same configuration as that of the active name node. Then if you want, you might even have a secondary name node which is for checkpointing. Checkpointing would mean for backup. And then you will have multiple data nodes depending upon your requirement of your size of your cluster. The RAM is pretty high here, 16 gigs. I really don't need 16 gigs. I have got systems which has got 8 gigs of RAM also in a lot of environments. Like in Amdocs, you have got data nodes with 8 gigs of RAM. So 16 is very, very good. So then the hard disk is 602 terabytes. Xeon with 2 cores, Ethernet power supply. We try to ensure that the OS is similar across all of the nodes in the cluster. A couple of you are asking me how should a real life environment is, right? So this is the way how real life environment would be. So this is the hardware configuration. Let's move on. So if you look at your Hadoop 2 cluster architecture, you will have on the master a name node. The port number for the master is 50070. So through that port number, you'll be able to see the details. In a small cluster, you may have your name node and your resource manager on one machine. But for anything more than 10 node cluster, it is always better to have it separately. So Rama saying, when you keep saying separately means two separate machines, exactly Rama. Because the purpose of, what is the purpose of your name node? It is to take care of the hardware requirements. What is the purpose of your resource manager? To take care of your processing requirements, right? So let me just go back to last slide, Rama. I want to make it clear, guys. Please note, active, standby, secondary are all physically separate machines in a production cluster. And each of the slaves are also physically separate machines. I hope that is very clear. Thank you, Ramesh. Appreciate that, Ramesh. And Jagan, clear on that? Cool. So again, Nakesh was saying, just to do checkpointing, why do we need a secondary name node with a high profile? Nakesh, the reason is because you will have to load that data into memory and then do checkpointing, right? Remember I told you there is something called as edits and FS image. So for loading it, you require to put it into memory. That's why. Cool. Arvind had a question. By secondary name node, only metadata up to a particular checkpoint will be backed up, and also we will lose data from the checkpoint onwards. But whereas passive name node will take care of it automatically. That's correct. Okay, Arvind? Good. Okay. He was saying that is the reasoning behind both of them. That's correct, Arvind. Rima was saying, but the same active name node works as a resource manager, right? No, Rima. Okay, it is going to be different. Asif, you haven't gone through the last time session. FS image is for the file system image, plus there is something called as edits. So these are the two things that will be there. Cool. Hey, no problem, Ramesh. We will be covering it up right now, Ramesh. Don't worry. So he was saying that he lost listening to what standby and this thing is. We will talk about it right now. Don't worry. Sunil was saying, why do we need a secondary name node when we have a standby name node in terms of a hard backup? This is for checkpointing. So that's why secondary name node is optional. It is not mandatory in architecture. What will happen if the name node and the secondary name node, both of them goes down? So it is there in the framework for a cold backup. Okay, Sunil? Cool. Nagesh said 32 MB is huge just to copy edits and FS image and to apply events from SF image and send them back. That's correct. So this takes a huge amount of resources, right? So checkpointing, if applying the edits in a cluster which is very big, applying the edits and loading that, where is everything going to be loaded? It is going to be loaded in the memory, right, Nagesh? Where is the FS image? FS image is there in the main memory. So I need that much amount of memory at least, or half of it, for loading it. Got it, Nagesh? Okay, let me document it over here so that I can thrash it out. So people are asking what is FS image and what is this, because it was there in the last time's document, friends. please don't forget what we have done last time, because otherwise it will be a little bit of a challenge, because I hate to proceed if people are not clear, guys. So that's the reason what am I doing. Okay, so let me go down and show you this over here. See, whenever we say that NameNode is going to store everything, see here I have said demand paging of the FS image. It will contain types of metadata and a transaction log. When I have covered these 2 points, I had mentioned what is this FS image. Okay, FS image is nothing but a snapshot of the file system image, and edits are nothing but the redo logs. Okay, it is nothing but logs. If you wanted to be take an analogy like the redo logs in Oracle, just as an analogy, Okay, guys. So just wanted it to be crystal clear what it is, guys. Cool. So this is what is the public information. Facebook has got 6,500 nodes in one cluster and has a total of approximately 40,000 nodes. Okay, cool. Let's continue. So here you can see this is the cluster. Every slave node would have a daemon for data node and the node manager. So this diagram shows you the difference between the cluster point of view. So if a client wants to do any file system job of putting a file, etc., he will talk to HDFS. That is the master, and NameNode will talk to the data nodes. When he wants to do processing, he will talk to Yarn, that is the resource manager, that will talk to the node manager. So this is what is the architecture. Now let's talk about federation. So this is what is the federation that we are having. Good. So this is what is federation that I had spoken about earlier. In Hadoop 1, there was only one name node. So the amount of data that you can put is limited by this name node. Whereas in Hadoop 2, you have got federation. So what is actually a federation? You will have multiple name nodes. So you will have a configuration file which will define what type of a data would go down to what type of name node or which name node. And then the data node is what is going to be a common storage. More details on this would be there in the link. Let me click on this link, and this link is absolutely fabulous. The Hadoop Apache link, let me copy this and put it into your questions window. This link is great because it gives you a lot of things. So on the left hand side, you would see that there is a HDFS user guide, high availability. This is a federation link that I have shown it to you right now. HDFS architecture. Then it talks to you about Mapreduce, and it also talks to you about Yarn. So this is the primary point of contact that you will have to look out for in case if you have any questions. The primary document, what I personally also look at in case if there is something that is not clear. Okay, so let's go back to the diagram and let me walk you through what it is going to do. So look at this diagram. So earlier we had only one name node. Now the advantage of having multiple name nodes would be that you can decide what has to go to each individual name node and the data is what is going to be a common storage. Let me ask you another thing. Just because I have got multiple name nodes over here for federation, does that mean am I having high availability? This is a very important question that should be clear to all of you. Just because I'm having 3 name nodes, does that mean I'm going to have high availability? Good, Vineet. Okay. No, 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 no. That's correct. Good. So a couple of you are saying yes. So the answer is no. Because I'm not having high availability, because if this node goes down, NN1 goes down, then I don't have another node where I will have a backup unless I'm having a passive name node. Exactly. So you need to have, if you want high availability and federation both in this architectural diagram, you should have 6 name nodes. Got it? So each name node is of a particular kind. Yes, that's correct. You should have 6 machines because there are 3 name nodes for federation, and for each one of them you should have a backup. That's why you should have 6. Cool. Mithun was asking, so as we have got multiple name nodes in Hadoop 2.0, so has it shared across multiple clusters because each cluster can have only one name node? No, Mithun. Each cluster can have multiple name nodes. One name node was in Gen 1, not in your Gen 2. Got it, Mithun? Cool. Hey, Ramesh had a question, so let me put this across. Sorry, let me copy what he was saying. Just one sec. He was saying that I have a doubt. We have got 1000 terabytes of HP storage. If I can configure 1 terabyte on each machine, 3 VMs, is it a good idea? As storage goes down, everything goes. It is just my assumption. Hey, in case if you have got 1000 terabytes of data, okay, and if you typically if you are having 3 virtual machines, remember there is going to be replication. So you should actually have to consider 3000 terabytes of data, Ramesh. You cannot simply go ahead with 1000 terabytes. It has to be actually 3000 terabytes because every block needs to be replicated 3 times. Cool. Good. So hey, the common storage is nothing but the block where you are having. Hey, the triangle is just to show you the name node, friend. That's all. Nothing else. Don't get confused with this triangle. It is just to show you that that is a namespace. Just writing the words. Okay? Cool? Nagesh was saying, what is the need to have a common storage? My dear friend, if every name node will have its own kind of data node, that will be a cluster, right? So the question is, you cannot communicate between clusters. Remember what Sneha had asked earlier? So whether you want to have 3 clusters of information or you want to have 1 cluster so that each of the processing can happen at a common storage. That is what you'll have to look at. Okay, cool. So this is about your federation. Let's move on. Hey, Annie was looking around the corner and she has got a question. Hey, Asif was saying block pools are nothing but collection of nodes. That's it. Yes, Rama, it has to be on a separate machine. That's correct. Common storage is nothing but something if you want to share across multiple things, that is what is a block pool, Asif. What is the advantage of having a federation? Jagan, earlier if you had only 1 machine, you will be limited by having it on 1 machine. Now you have got 3 machines to store your name node. So you are having scalability at the name node level also. Fantastic. Thank you, Krishna. I really appreciate that. Looks like Brendan McCallum wants to finish it off in 20 overs. That's nice. Let's cheer for New Zealand. Good. That's correct, Asif. Federation would mean you will have not multiple copies. Federation means you will have more of RAM and you can store. Imagine if you have got 1 system and if you have got 64 MB RAM, how much amount of metadata can you store? Only 64. But if you have got federation, if you have got 3, you can say 64 into 3, right? That is the amount of data that you can store. Cool. Kirti, the configuration for federation is all done in the setup document. So if you wanted to do it in a multi-node cluster, because here we are talking about a pseudo cluster, in a multi-node cluster, if you look at the document, all about federation is mentioned about in the page itself. Cool. So Ramesh was saying, I'm confused with normal yarn setup and federation setup. Can you explain both? Hey, we are talking about a normal setup. This is a pseudo node. If you wanted to do something about a federation setup, if you look at the document, what I had shown it to you, there we go. Let me open up the page, go down. They have given you details about how to do it. See, including the configuration files, everything is mentioned over here. If you simply follow the instructions and if you've got physical machines, you can easily do it. Okay, Ramesh? Cool. Vinit said so, but each name node will store the state of all the data nodes. hey, the name node will store the blocks in the memory, right? Why should it store the state of all the data nodes, Vineet? What is there in the name node? It is having pointers to the data that is there, right? Okay, fantastic. Yeah, that's right. Cool, Nagesh. So now coming back to this question, tell me, how does federation help name node scale horizontally? Reduce the load on any name node by using multiple independent namespaces, or provide cross data center non-local support for HDFS, allowing a cluster administrator to split the block storage outside of the cluster. Vineet, how can it provide cross data center non-local support for HDFS, Vineet? You had said B by mistake, or did you wanted to say A? Do you really wanted to say B? Because you cannot store anything outside the cluster, right? So the answer is A. Okay, cool. Good, Harsha. Good, Jayashree. So the right answer to this thing is A. So it reduces the load on a single name node. So that is the whole idea of it. Fantastic, Kalyan. Let's continue. So the option is A. In order to scale the name service horizontally, federation uses multiple independent name nodes. Name nodes are federated, that is, they are independent of each other and do not require coordination with each other. Perfect. So good. Now, just to ensure that you are clear on it, I have got a cluster. Hey, before we go ahead, one final question. I have one name node with 6 data nodes. Do this kind of setups federation mode of clusters is suggestible? No, Ramesh. If you are having one name node with 6 data nodes, it is not a federation, right? So a federation means you'll have multiple name nodes. Cool. Hey, let me go back and look at what Kirti was saying. Now, if I want to implement this, you can do that. Why not? If I want to implement one name node with 6 data nodes, you can easily do that. As long as you have got physical machines, you can easily do it, Ramesh. But then that is not federation. If you want federation, you should have multiple name nodes. Cool. Now coming back to this question, what are we seeing over here? There are 2 name nodes to manage. There is a slash marketing which will be taken by the first name node, and there is a slash finance what is there in the second name node. Now you try to put in a file into an accounting directory. What would happen? Okay, will it work? Will it fail? These are the 2 issues what might have. Okay, good. Framework will complain. Very good, Vineet. He is saying there is no accounting directory, so how will it store it? Very good. Yep, it will not work and it will fail. That's correct. Cool. Sneha had a question. Federation is basically used for real large clusters with huge data when compared to Hadoop 1.0. Is it correct? Federation, yeah, you're correct, because why would I need federation? Because I simply don't have enough of RAM to store all the blocks. Cool, you're correct in that. Okay, hey, very good. Mallikarjuna was saying federation is for high availability. No, I told you some time back federation is not for high availability, Mallikarjun, because if you are having 3 nodes, is there a backup of it? High availability means backup. You'll see it in the next slide, Mallikarjun. Cool. So federation is all about providing scalability to the name node. That's correct. Horizontal scalability is what is the right answer. In case of federation, only one node can perform checkpointing for all the data nodes or for all the name nodes. That's correct, Nagesh again. Cool. Good. Yusuf said, using Edureka VM, how many data nodes can we create for practice? By default, you have got only one data node. If you want to have multiple data nodes, you need to have physically separate machines, and then you'll have to configure it yourself. Okay, cool. You will see it in the next slide, Asif. What is the meaning of high availability? Okay, cool. Hey, tell me folks, what were you saying? Kirti was saying, can you show us what kind of exception, etc. will be shown when you put it into the accounting directory? Good point, Kirti. The exception that will be shown is no such file or directory. See here, the answer to this earlier question was put will fail. None of the namespaces will manage the file, and you will get an input-output exception saying that no such file or directory will exist. Cool. If only one secondary name node is available as a checkpoint in a federation, so the size of the secondary name node should be equal to the sum of all the name nodes? Yes. So that is what is the underlying assumption. Very good, Tanuja, for bringing that out. Can I have multiple VMs running simultaneously to test multiple nodes? If your base RAM, if your base system has got more than 8 gigs of RAM, then it is possible. In 8 gigs of RAM, you can run only one. You can try with multiple VMs if you have got 16 gigs of RAM. Let's go down to the next one. So this is high availability. A lot of you are asking me, what is high availability? So this is what is high availability. So if you look at the link that we have, so whenever the client wants to talk anything about HDFS, at one point of time you can have only one name node that is there in an active location. Okay, so whatever entries are made in this active name node. At the same time, the edits file I told you, right, they are kept in a NAS, that is in a network storage. And the standby name node will keep on polling the shared edit log to see if there are any changes that is happening to that, and if it is happening, it will make it in its own copy. So that is the way how the active name node and the passive name node are always in sync, okay, through something called as shared edit logs. So the standby will read the edit logs and apply it to its own namespace. You can also have a secondary name node, but it is not necessary to configure it. Okay, you will have data nodes who will keep on polling both the active and the standby name node so that the block reports goes to both of them. A beautiful description of that would be there in this link. I have already opened up this link before, so let me go scroll up in my document, and if I show you high availability with NFS, there are two ways of high availability. You can have high availability using Quorum Journal Manager, or you can have high availability using a network file system. Okay, so let's look at what is this high availability. This is the section that is most important for you to understand. So in a typical high availability cluster, two separate machines are configured as name nodes. At any point of time, only one of the name node would be in an active state, another would be in a standby state. The active name node is responsible for all the client operations. In order for the standby to keep its state synchronized with the active node, the current implementation requires that two nodes have an access to a directory on a shared storage, that is an NFS or a NAS mount. So this restriction will be relaxed in future. So whenever any namespace modification is performed by the active name node, it logs a record of that modification to the shared edit file in the directory. The standby name node is constantly watching this directory for edits, and as it sees the edits, it applies them to the own namespace. So that in the case of a failure, the standby will ensure that it has read all the edits from the shared storage before promoting as an active state. So this ensures that the name node state is fully synchronized before a failover occurs. This is what is the way how high availability is done, folks. Make sense? Fantastic. Okay, Nagesh is saying if NAS fails, NAS is a network storage. The possibility of a NAS failing is nil. It is going to be a NAS fail. It is a network storage, so the possibility of the whole network going down is very, very rare. Right now, how many copies of data are you having, Nagesh? You will have a production system and you will have a disaster recovery. What will happen if both the production and the disaster recovery goes down? Possibility is rare, right? Because the disaster recovery is always in a separate location. So that is the case. Cool. So Kiran was asking, is something like Zookeeper working here? Exactly, Kiran. So internally it is going to be Zookeeper. So now, just give me one sec. Mallikarjuna was saying, in case of active name node failure, secondary will start as the primary. In case of high availability, no, Mallikarjuna. Look at this diagram. Am I having a secondary or am I having a standby name node? Let me open up the diagram. See over here. If the active goes down, is the secondary name node in sync? No, it is the standby name node in sync, right? So it is going to be the standby that will come up, Mallikarjun. Hope it is clear with you. Cool? Good. Okay, good, Mallikarjun. Sorry, I saw your message after that. So he really said not secondary, I mean passive. That's correct, Mallikarjun. Ramesh was saying, is there any general stuck point while failing over to standby? No, not at all. The framework is going to take care of it. Hey, fantastic. So this is a link what was shared by Rama. Let me go down to the browser and copy this link for you guys. Control V. I'll press enter. So this is Raspberry Pi view topics. This is raspberrypi.org. This is what he was talking about. So this is the link what you will have to look out for. Okay, cool. Thank you. Let me go ahead and paste it. This is another link what Rama had also shared. He's talking about adafruit.com product. Let me look at that link also. Just give me one sec. Control V. You can look at that link also, guys. There we go. So this is Raspberry Pi model. There it is. Okay. So it's a hardware kind of an equipment and you can look at it. Fantastic. So let me minimize this. Thank you so much, Rama. I really appreciate that. High availability is basically seeing logs that are shared. Yes, that's correct. Hey, Yusuf, in my diagram, the resource manager is not going to come because we are not talking about processing right now. On the right-hand side, you see what I have hidden. Okay, what is not been shown. You will see the resource manager coming up after that. So Praveen was saying, is edit log stored in a separate machine? How many of edit logs are kept? Hey, edit log is just a temporary log that will be there, which will have the details of whatever edits are happening. So it is stored in an NAS. Okay, Praveen, good. Let's go back. Let's continue. So this is about your location of or an idea about what is high availability. Now let's continue. So this is just a more detailed diagram about what would happen in the case of a high availability. There is a shared edit logs that is there in your NAS. You'll have active name node which will read and write to it, and the standby name node will read it. And all the data nodes will ping up both your active and your passive name node. Cool. Hey, Crazy Pi is another site. Okay, so it is a site for download. Vijay was asking, after a failure of active, standby will work as active, but which will do the role of standby during this duration, and what will happen if active comes back? It will again be active or passive. Good point. Whenever the standby comes up, you will not have another standby to the standby. Okay, so that is the time when you will have to do to ensure that you will try to do an analysis of what is the reason why the system has gone down. If the active comes back again, it will become as passive. It is not going to be active again. That is the way how it works. Good? Makes sense, Vijay? Good point. Manish, what is the date container and the app master? I had mentioned it to you last time, Manish. I'll cover it once again. Don't worry. That is the processing part of it. We'll come down to that. Cool. Ramesh said, when active name node goes down, when does the secondary name node will do? Secondary name node will simply have a checkpoint of everything. Secondary name node, if the active goes down, it will, secondary name node will always take its data from the NAS. Okay, it is configured in such a way that it will look at active and passive both together, Ramesh. Okay, cool. So now there was a question about what is this container and what is this app master. So we are going to talk about what is container and app master as we go ahead, because that is a part of the node manager. That is the processing part of it. Right now we are looking at the HDFS part of it. We'll come down to that, guys. Fantastic. Let's move on. So this is the high availability. Now comes the resource management. So if you want to talk about what is the way how the processing happens, hey, one question before I move on, let me go back to the earlier slide, a suggestion made by Jagan. Why arrow from the client points to the shared edit logs instead of the active one? Just one sec. Let me go back and send this to everybody. Let me look at this arrow. The client will, this is not technically correct. You're right on that. The client will talk to the active name node and the client will not talk to the shared edit file. I didn't even see this. This is not correct. Client will talk to the active name node and that is what will point to it. Another good point. So that was a very good point, Jagan. I didn't even see that. Trust me when I say that. Cool. So now let me go ahead. Asif was saying high availability, federation, rack awareness is in second generation for better performance. Hey, high availability and federation is in Gen 2. Rack awareness was in Gen 1 itself. Okay? Cool. What's active in high availability? Active in high availability is a current node which is taking care of all of the requests. Yusuf had a question. In HDFS federation diagram, when we have multiple name nodes, will client can create connections with multiple name nodes for putting in the request? No, the client will only, there will be an XML file, Yusuf, good point. There would be an XML file which you have to configure to let the client know if you want something which name node he should point to. Okay, Yusuf? Cool. Ramesh said, secondary name node used to stick to the name node. Hey, what is this? Used to stick to the active name node as per the diagram. If the active name node goes down, will it tail start with no address? No. In the second, okay, let me go back to this diagram. I think I know what you are trying to ask me. So see here, secondary name node is pointing to the active name node. So what he is saying is, if the secondary active goes down, what will happen? Secondary name node will have the details of both active and passive. Okay, I mean standby. So whenever whichever becomes active, secondary name node will piggy bank on that. That is what would happen. Okay, cool. Hey, that's nice. So even Arvind is saying, appreciated Jagan's keen observation. That's good. Share that with me. Let's all improve this thing ourselves. Cool. Asif was saying, there's read and active data node. It's only write. Hey, it could be read and write both, Asif. Okay. For processing, you will communicate with Yarn. You will have a resource manager who is the master of all processing component. The actual work will be done by the node managers. The place where the actual data would be processed would be there in a container. Container is like a JVM. One of you had asked me what is this container. So let me go back and document it so that it becomes clear. Container is the actual Java virtual machine where the processing happens inside a node manager. Okay, then what is a app master? Okay, there will be a single application master for every job. That is what is called as a app master. Okay, friend, there would be a single application master for every job. So that app master is also going to be running in a separate Java virtual machine on the node manager. And then, of course, your actual data would be taken up from the data nodes. Please note the node manager and data manager is going to be running on the same machine, friend. Got it? So it is not going to be on separate machines. It's going to be on the same machine. Thank you, Kirti. I got your email. I saw that. Hey, Vinit, we just started right now. So I'll tell you what is App Master. Okay. So for every job, there would be an App Master. So in the earlier version, the job tracker, that was a daemon that was used, was taking care of all the resource management. It was getting overloaded. So that is the reason why we had something called as a what do you call app master component created so that every job's resource management will be taken care of by the application master itself. Okay, that's what it is. Cool. Thank you. Hey, Rama was saying, so you mean to say there are two separate JVMs within the node manager? Hey, there could be multiple JVMs taking care of the processing in the node manager. Okay, cool. Okay. So Ramesh was saying if there are 10 jobs, 10 app masters will be created within the single container. No, my dear friend, there will be separate app masters, JVMs that will be there. Container is one VM where the actual jobs are processed. Your app master is another VM where the jobs are processed. You'll see that in the next couple of slides, guys. We'll actually see it. Okay? Don't get confused right now. We will actually see it. Cool. That's correct. So if you have got 10 jobs, you will have 10 separate JVMs for the app masters. Okay? We had seen what is our, let me go back to the earlier slide. Yeah, I was talking to you about the client submitting a request to the resource manager. Resource manager, that is a master, would have a scheduler. Scheduler is a way how he schedules multiple jobs to be executed in the different nodes. There is going to be a applications manager. So this is the component which will start the application master per job on a respective node manager. The application master will get the job done by the different containers where the data is. So what is a container? Container is a JVM where the processing of your data would happen, and on which node the container has to be started is all taken care of by the resource manager. So this is what is the way how the yarn would work. What is yarn? It is yet another resource negotiator. Okay, friends? So these are the different components what we are having. Cool. Manish had a good question. Will resource manager have multiple instances? No, resource manager is a one component. If the resource manager is down, then no processing can happen. For HDFS, for high availability is important, but then for processing, there is no high availability. Got it? Hey, yarn is a concept like big data and Hadoop, right? So yarn is just a framework, is a concept, yet another resource negotiator. All the daemons inside yarn is called as resource manager, node manager, etc. So there are different components in that framework. Yarn is a framework, and there are different components inside that framework. Perfect. Let's continue. So now let's go back. Annie was around the corner, so she's asking something. Hey, Sneha was asking, in real environment, what are the possibilities of the resource manager to go down, how to overcome this? See, if the resource, in any environment, all of your working people, guys, so you would know, whenever there are systems, there is a probability of a system going down, maybe for anything. But these are server grade machines with dual power supply, etc. If something goes down, then the cluster will be down at that point of time. So that is the simple way how it would happen, Sneha. Make sense? Cool. There is no high availability for the resourcing component. There is a high availability for the no. So a high availability is there for the metadata, because if the metadata goes away, the whole cluster is down, right? But there is no high availability for the processing framework. Cool. Mani said, why not? Because my overall framework is not robust. No, my dear friend. See, when we talk about processing, what is more important? The metadata is more important, the data storage, because if the name node is down, I will lose everything, although you got a backup and all that. Think of this way, Manish. How many of your systems are really 100% what do you call resource aware? You talk about Teradata. Would Teradata be highly available? No, right? Because Teradata is expensive, so for analysis, will I keep a highly available system? No, so that is a reason. Can you explain between app master and app manager and resource manager? Sure, Kiran. I'll explain it with an example as we go ahead. Perfect. So the question was, let me go back to the earlier step, then I'll come back to this. What are the difference between your app master and the resource manager? Resource manager is one component which takes care of resource management for all the jobs that is there in the cluster. App master is the component which is going to take care of the life cycle per job. That is the difference between both of them. Cool? Got it, Kiran? So the job can wait because it is done as batch, so resource manager doesn't need a real backup. That's correct. See, the possibility of a resource manager going down is there, but then you can't have high availability for everything, right? Are you having a high availability for your analysis component? No, you will have a high availability for your customer facing records. Cool. That's correct. App master will be executed in a JVM, Manish. Okay, so like I said, your container, the actual work will be done by containers in a JVM. App master is also another component which will be executed in a JVM. Now let's get down to Annie's question. HDFS high availability was developed to overcome which of the disadvantage of Hadoop 1.0? What is it, guys? Why did we have high availability? So people have answered before, you can re-answer it. Is it because of a single point of failure, or is it because of only one kind of a code can be executed in classic Mapreduce, that is Mapreduce, or too much burden of job tracker? Good. No, it is not all three, it is only one. It is not three. High availability was there primarily because, like all of you have said that's very good, guys. Most of you have got the answer correct. You have got Manish, Mithun, Jayashri, Kalyan, Praveen, Kiran, Vineet, Reema, Sunil. Okay, it is one. Asif, it is not three, it is one. High availability is there because what will happen if the name node fails? It has got nothing to do with the job tracker Asif. It is A, high availability is because of single point of failure of your name node. So let me go down to the next slide and you'll see the answer. So HA was because there was a single point of failure. So now, if you look at the link that I have shared with you earlier, that is Hadoop powered by, we are giving you an example of a Hadoop cluster of Facebook. Facebook uses Hadoop to store the internal log and dimension data sources. They use it as a source for reporting, analytics, and machine learning. They have got 1,100 machine cluster with 8,800 cores and almost 12 petabytes of storage. Another cluster has got 300 machine cluster with about 3 petabytes of storage. For them, every node has got 8 core and it has got 12 petabyte of storage. They use all type of analysis, and Facebook is one of the components which has helped you in creating a SQL layer that is called as HIVE. So HIVE was developed by Facebook. Cool. Kiran was asking what is machine learning. Machine learning is, you have seen it in the slide in our day one, Mahout. Machine learning is a concept wherein based on algorithms you will be able to have meaningful information out of the data. That is what is machine learning, and Mahout is a component for machine learning. Cool. Yes, one cluster has got 1,100 nodes. It says 1,100 machine cluster. That means one cluster has got 1,100 nodes. Okay, Asif? Nandish had a question, just wondering, when a job is sent to the container for processing, is the JVM start fresh for every job, or it's one-time initialization like a web server JVM? It is one-time installation, Nandish. Okay, you don't have to restart it. The JVM can be reused, because there is an overhead in stopping and starting up of a JVM. That's why. Cool. Let's move on. So now Hadoop can be executed. Let me go down to the next slide. There it is. There are three ways in which you can run Hadoop. Hadoop can be executed on your local machine in the form of a local mode. There will be no daemons running. Okay, everything is run only in a single JVM. It is only good for Mapreduce programming. Other than that, it is not of any good use. And you don't have a distributed file system also in your local mode. The mode that we are running is a pseudo distributed mode. In the pseudo distributed mode, all daemons are running on the local machine. So how do I know whether the daemons are running or not? So let me go back and let's go down to our VM player. So when you go down to the VM player, please log into Edureka. I am going to do the login. It will come up, and when you go down to your terminal window, let the VM start. We will type something called as sudo jps, and you will see if the daemons are running. Okay, exactly beneath. Perfect. You will say sudo jps. And in a fully distributed mode, you will have multiple machines, and on different machines, different processes would be running. What will be running on the masters? You will have a resource manager, node manager. You will have a secondary name node also running. And on slaves, you will have your data node and the node manager running. So this is what would be a configuration of a fully distributed mode. Good. Let me go down to the next slide. So now it is very important that you should know what all are the different configuration files that we are going to have. Okay, so just give me one sec. Let me go down. Have I freeze my screen? No, good. So there you see. So these are all the various configuration files what you have in your Hadoop. You will have a file called as hadoop-env.sh, which is the scripts that is needed to start with Hadoop. You will have a file called as core-site, which will have configurations for all the core components of Hadoop, then hdfs-site, mapred-site, yarn-site, and a file called as masters and slaves. So the three XML files are, in fact the four XML files are for different components. Masters will contain the IP address of all the secondary name nodes, and slaves will contain the IP address of the data node and the node manager, that is the slave machines. So this is the way how you will have your different XML files configured, friends. Okay. So now let me go back to the terminal window, and I should have my VM started. Let me go down to my VM. So I am there in my terminal window right now, and let me type sudo jps, and it will ask me for a password. It is going to be called as Edureka, and you will see the services running. You might also see a history server running, so don't worry. For me, I don't have the history server running because I haven't started it. So you see that there is a name node and there is resource manager. These are all daemon processes running. You will have a data node and a node manager. That means everything is going to be running on a single machine. So we are having a pseudo cluster over here. Exactly. History server is for understanding the history of all the jobs, Manish. Okay? Cool. Yeah, that's right. The VM is a pseudo VM. That's correct. So let's go ahead and have a look at some of the XML stuff. So where is Hadoop installed? Hadoop is installed in USR lib Hadoop. In that, if you go down to the etc Hadoop, you will see everything over there. And if I type HDFS, it will give me a list of commands. That's what I'm going to do it right now for you. So let me go down to the VM. I will say cd space. You can do this comfortably at your end also, but then right now please watch /usr lib Hadoop, then etc Hadoop, and if I do a ls, you will see all the scripts that I have spoken about would be over here, friend. Okay? I spoke to you about core-site.xml. I spoke to you about mapred-site.xml. I mentioned about hadoop-env.sh. I mentioned about hdfs-site.xml, and I also mentioned about yarn-site.xml. So all the different XML files that I said is over here. And if I just type Hadoop and HDFS and press enter, it will give me a list of commands. So you can see over here, HDFS would have a very important command called as DFS. That is how you will be running your distributed file system, and these are all the various other components that can be executed. Okay, so hope this is clear. Vinith was asking what about masters and slaves file? Yes, masters and slaves are also there. So if you scroll up and see, you will see your masters and slaves. So you can see here slaves over here, and you would be able to see masters. Let me go ahead and check. Masters file should also be there. If it is not there, since it's a pseudo cluster, maybe they haven't kept it. Let me do one thing. Let me do a ls and see it once again. ls space minus all, and let me scroll up. Okay, since this is a pseudo cluster, we don't have a secondary name node here. So masters will contain the secondary name node, right? So that's why on this VM secondary name node is not there, but you are having the slaves file. Masters file is for the secondary name node. Got it? Cool. Hey, Mithun, you will be seeing that. We are definitely going to walk through the XML files at a very high level, because in detail is what we'll be covering in a sample example class. But then since this is a developer class, we won't be covering everything in detail, but then yes, we will be touching base on it. Let's look at the slides, and it is coming up. So let me go down to the next slide. So when I type Hadoop, it will give you, we did HDFS, right? So HDFS has got a set of commands, and when I type Hadoop, Hadoop also has got a set of commands, and the most important purpose of Hadoop is for running a jar file. This is what we'll be doing it in our Mapreduce, how to run a jar file. Okay, cool. Let me move on. So there are various XML files that we covered, right? So each one of them is for a different component. Your core-site is for the core component. HDFS, what is inside that file? We are going to quickly have a look at it. HDFS-site, yarn-site, and finally mapred-site.xml. Let's continue. So what do you write in your core-site.xml? You specify the IP address of your primary name node. Okay, so there is a property called as fs.defaultfs. Okay, and the value of that is what you will have to keep it as HDFS : the IP address of your name node, that is active name node, and pointed on by the port number on which it is running. It will be running on the 9000 port number. Okay, so this is what it is. Cool. The purpose of each one of these things, you will be seeing it. So if you go back to the VM, so you might be asking, is there only one property in core-site? No. There's a lot of properties, and what does this contain? This, what you are setting up the property, is nothing but the IP address. See here, the URI authority is determined the host port number for the file system. That means you're specifying the IP address of the name node. If you want to have an exhaustive list of it, it is there. If you go down to the link that I had given earlier, that is your documentation link. And if you scroll down, do you see something called as configuration, and do you see something called as XML files? Click on your core-default.xml, and it will give you the complete listing of the different properties what you have. Okay, you will be given the name of the property, you will be given the value, what is the default value of the property, and you will also be given the description of the property. Okay, so we said fs.defaultfs, right? So what is the property that we wrote in our XML file? fs.defaultfs, right? So let me go over here and do a Control F and search for fs.defaultfs. Did I not see something called as fs.defaultfs here? See over here. And what is the value of that? See over here, the details of your default file system. So that is nothing but the IP address of your name node. Got it, friends? Exactly. So core-URI stands for Uniform Resource Identifier. Sunil was asking what is URI. URI stands for Uniform Resource Identifier. That is what is the IP address what you are talking about. Core will be something that is going to be common for both your storage and the processing part of it. Cool. Mithun said, can I set the property value through Java instead of XML? No, you will be required to store everything in the form of an XML, but you can override it in the form of a Java code. Okay? What command gives me the NameNode IP address? How do I get the IP address of my system? You will be able to do it through ifconfig. If you want to get the IP address of your system, you will have to know on which machine it is running, and then you will have to type ifconfig, and that's how it will come. Got it, Sneha? So here we are running a pseudo cluster, and that is the reason why we are writing everything as a local host. Got it, friends? Let me go back to my PDF. So we will be talking about what are the important things inside each of these things. No, it is ifconfig because this is Linux and not ipconfig. Ipconfig is in Windows as if this is ifconfig. Cool. So then what do we do in our hdfs-site.xml? You specify what is the replication value. The reason why I'm setting the replication value as 1 over here is because we are having a single node cluster. Okay? Then you give permissions. Okay, so if the permission is false, then the permission checking is turned on or it is false. The NameNode.dir will be the location where the FS image is going to be stored. So I told you there are two things, right? There is something called as FS image and edits. You will see that inside this particular directory. I'll go inside and show it to you. And then the data.dir will contain the place where the actual block files are going to be stored. Remember we said about blocks of 128 MB? This is the where how it is. Okay, so if you ask me what is this permission checking, whether if a user has got a permission, this is the authorizations. Permissions is authorizations. Okay, by default, the security is not enabled over here. There is no authorization that is there. Okay, so if you have got security settings, then you can say permissions as true, Manish and Partha. Got it? Cool. Kirti was saying there is a property temp.directory. Is this where your federations are configured? No, federations are configured, Kirti. I have given you separate XML files. So if you look at the link what I had shared, inside that they have given details of federation. So there will be separate XML files. Since this is a pseudo cluster, we are not having those properties over here. Krishna was asking which process reads these XML files. These XML files are read by the daemons when you start your cluster. Whenever the cluster starts up, all these things are selected. Prasanna was asking, does permissions mean Hadoop can manage tenancy? How can a client get authorized to write to HDFS? By default, your security is not enabled. Security is enabled through something called as Kerberos, Prasanna. So in case if you don't have a Kerberos setting that is there, that is what is the DFS permission. So it will give a access to everybody to do anything who has got an access to it with an IP. But with Kerberos, I can say you can have authentication and authorization enabled. But it doesn't mean tenancy. It would mean, of course, the tenancy can be a part of your authorization also, Prasanna. Good. Any changes to these XML files would needs to restart, or is it a hot deployment? Typically, any change in XML files, you'll have to refresh the daemon so that it can read these XML files. Think of it like an application. You change a web.xml, it's a hot deployment. But then in case if it is any server deployment, you will have to refresh your servers, right? So XML files are, since it's read only once, you will have to make the processes read these XML files. Cool, friends. So now let's go ahead and see if there is an FS image in your Hadoop. Inside that Hadoop to data HDFS name node. So I'm going to go ahead and show that to you. So if I do pwd, give me a sec. There we go. I type pwd. I'm in Hadoop. Let me say ls. Sorry, I am inside Hadoop conf. No, let me go 2 levels up. cd space // and if I do ls over here, there is a folder called as Hadoop to data. So I will say cd and I'll go down to Hadoop to data, and inside that there is HDFS, and inside that there is NameNode, and inside that there is current, and if I do a ls, you will see that there are multiple FS images. Just give me one sec. See here, there are multiple FS images and there are multiple edits. Okay, so this is the way how your file system image and your edits will be stored, all taken care of by the framework. Cool. Mallikarjun was asking how to refresh the domains. There is a command called as refresh. Along with each of the name node, you will say Hadoop HDFS name node refresh, and it will refresh those daemons. Cool. So Asif was saying logs of the file check. What do you mean by that? Logs of the file check, Asif? Not very clear on that. If you can elaborate, friend. So what we saw right now was a quick way as to how to look at the different things. Now let me go back to my PDF. Now, if you go down to the next component that we have, the XML file, that is mapred-site.xml. So mapred-site.xml will have the name of the framework that you are going to use for processing. By default, you can use local, that is local file system. You can use classic, that means you will use your Gen 1 Mapreduce, or else you can use Yarn. That is the new resource management framework, and what you see is in our XML file, we are using Yarn. So in our VM, we will be working with Yarn. Asif was saying fslog is the logs of checking. Fslog is a file system image. Edits is the file which will have the logs of the check-in. Okay, Asif? Good. Partha was saying where the name node has all the data node information, where reconnected to it, etc. Hey, the name node will have the details of the data nodes in which file? In slaves file. I showed you earlier, right? Slaves will have the IP address of all the data nodes. So the name node will get the information about the data node from the slaves file, Partha. Good, Mallikarjun. Now, let's get down to the last of the XML files, that is called as yarn-site.xml. This will have, there are two mandatory attributes that you should have over here. What is the auxiliary service name, which will actually do the work, and what is the class that we will have to use for making work with it. So these are the two properties that we will have to keep. It exactly has to be this because you don't have any other auxiliary services right now, but going ahead you might have multiple auxiliary services that will be there. So as of now, we have got only one. So you'll have to give the value as Mapreduce shuffle and the name of the Java class which actually does the shuffling part of it. So which are the XML files we saw? Core-site, HDFS-site, Mapred-site, and Yarn-site. So if you go down to this link, all the details of all the properties what is there in the XML files is available over here. This is nothing but the same link what I had shown it to you for core-site. You can see an exhaustive list of it. Hey, auxiliary service would mean the service which is actually going to internally take care of your shuffling, etc. That is what we will be seeing it in our Mapred. What do you mean by services? What do you mean by shuffling? Okay, you will have to click on this link so that you'll come to know what all are the detailed properties that is there. Now, if you wanted to see your services and see if everything is fine, you can go down to these URLs in your VM and you can actually see the details of whatever is happening. Hey, Hadoop-env.sh will contain the JVM. We will see that as we go ahead, Madhu. So let me go ahead and show it to you if this is running. I'm going to show you the name node and the resource manager. So let me go back to my browser. And once the browser comes up, I will go down to my name node status. There is a shortcut that is there. So you can see over here, there is Hadoop name node, there is a shortcut. And you can see over here that the security is off by default. Remember, we have said that the permissions is not there. Okay, and this will give you the details of it. Cool. Hey, Mithun was asking, can you show us the env.sh? When a client does read or write, how does HDFS take information from Hadoop-env? The env.sh, Mithun and Madhu, if you look at it, will only have the Java home. That's all. The client will not look at the env file to pick up that information. The control will first go down to the name node, right? So if you're interested in env.sh, let me quickly go ahead and show that to you. So let me go down to the conf directory. I am in a separate location, cd, let me do pwd, let me see where am I. The only thing that will be there is your JVM location, cd space dot dot slash dot dot slash dot dot slash dot dot slash. Then I will say cd etc Hadoop, and let me say gedit my Hadoop-env.sh. I have opened up editor. So see over here, this is the gedit, and if you scroll down over here, this is the only information what is important for you. This will give you the location of what is your Java implementation, and then what is the default class path and all of those things. That's all. Okay? What is the logs directory, what is the details, etc. So this is versus the basic environment setting. I would strongly encourage you to have a look at this so that you will get a hang of what it is. Okay, guys? Cool. Fantastic, Krishna. Good, Mithun. Who reads the env name node? Hey, it is read by the name node, of course. At the time when the system starts up, in fact, all the components would need to read the env to know the Java locations. You can go down to the resource manager to see how many jobs are there, localhost 80, 88, and cluster. Let me go back to the browser. I showed you the name node. If you go down to localhost 80, 88, let me open up another tab. I would say localhost 80, 88 and cluster. This will give you the details of the resource manager. And on your own machines, if you go ahead, you would be able to see the details. See, this is the resource manager, all applications, how many applications are running, etc. The details of all of that will be shown to you. Okay, and you can try the job tracker history server also. Okay, at this particular URL, I have to start with the history server. Let me do that for you so that you can see that URL also. So let me do pwd. Let me go 2 levels up, and let me go down to the bin, and I will say start, sorry, / mr hyphen, or I should say start, sorry, just give me 1 sec. I should go to sbin, okay, and / I will say start history server. That is the command. My history server is running. So if I type sudo jps, you don't have to do that because you already have this. And if I type in my edureka as my password, you see the job history server is also running for me on a particular port number. And now if I go back to my browser, and if I another link, and if I go ahead and say localhost, you would be able to see the job history server details also for you folks. Wait for a couple of seconds. It is just taking some time to start it, and it will come up for you. Okay. So hey, that's right. So there will be every data node will have to ping to the name node every 3 seconds. Okay. So Kishore was saying, I had missed the second questions log and these nodes. Can you share the links? Hey, I have already given the link earlier, Kishore. Do you have the copy link with you? In the copy link, everything is there. Can one of you please post the copy link once again? Hey, Kishore has again gone offline. Looks like he is having some issue. Okay, so now if you look at your details, see here, these are all the different jobs that I have executed. And if you look at a job ID, it will go down and give me more historical information about the job. Okay, hey, the job has actually been finished, so that's the reason it is not there in that. So you will be able to see the running jobs. These are all the retired jobs. So whenever we do a job, you'll be able to see it. It should be there in your applications. And let me go down to the finished jobs over here. So I have cleaned up the system, so that's the reason why you're not seeing it here, but otherwise it should show you all the applications that is already finished, guys. Okay, so those are the information that will be over there. So you can get your configuration details, everything from these links. Wanted to actually show you a demo so that you can see what it is, guys. Okay, cool. So let's move on, guys. So now, where do we specify the heap size for the daemons? Which XML file will we specify the heap size for the daemons, guys? No, friend, it will be there in Hadoop-env.sh. Couple of people are saying NameNode, data node and all that. The heap size will never be there in the NameNode or in the XML files. XML files will only have the IP addresses. The details will be there in Hadoop-env.sh. Okay, cool. Now, the next thing is it necessary to define all the properties? No, not at all. It is not necessary because you will only have to override the property what is needed. You saw that there was a huge list of properties. As if, did we overwrite all of them in our XML files? No. Okay, the answer is false. The detailed answer will be given after the next question, but then you know what it is. In core-site, I showed you that link. There was an exhaustive list of properties, but we did not override all of them because we will override only the properties that we need. Good. So now there is a mode called a standalone mode, right? I said that is good only for Mapreduce development. So in that, does it use the default configuration? Yes, if you're not aware of it, I think the answer is yes. Very good. That's right. Good, Nagesh. So the default configuration is used by the standalone mode, and you will see the answer. See here. Let me go down. In a standalone mode, Hadoop always runs with the default configuration. That means you will not have any configuration files, and it will pick up all the default from these XML files. So if properties are not defined in the configuration files, the Hadoop runs with the default values for the corresponding properties. I hope that is clear to all of you guys, right? So you only override the properties what we want. The other properties, we don't touch it at all. Cool. So now we are going to go ahead and see a small example. There is inside your share Hadoop Mapreduce, there is a jar file which will contain a lot of default applications that we can try. So we need to go down to your Hadoop. Inside that share Hadoop Mapreduce is where all the XML files are. So let me go ahead and show that to you. Let me go down and start with the terminal window. Okay, let me type do pwd so that I know where am I. Let me go up one level. I will say cd share, then inside that Mapreduce, sorry, inside that Hadoop. Inside Hadoop, there should be Mapreduce. Yeah, there it is. And if I do a ls over there, you will see that it has got a very common application called as Hadoop-Mapreduce-examples file. So this is the file that we are going to run it and see what is there inside this file. Cool. Hey, Asif, all the links are there in the PDF for you, my dear friend. See here. You go down to the PDF and all the links are there for you. Let me go back and see here. You have got all of these details, so you don't have to remember anything, Asif. All the details are there for your friend. Okay? So now what am I going to do is, I am going to run that particular jar file and it will give me the list of applications. That is what I'm going to demo it to you so that it will be clear how to run a standard application. What is happening, as if this PDF is of course there in your LMS in your module number 2, friend. Just one sec, Partha, I will do pwd, and you can see here. So guys, one of you can please ping me the link for the copy. I'm sorry, friend, I don't have that. That is it. Thank you so much, Neha. So Kishore, here it is. Thank you, Sneha. So Sneha has given us this link. Let me copy this link. Please save it, guys, all of you guys. You would need this. This is the place where I'll share everything. Just give me 1 sec. For some reason, it is not clicking. So thank you, Vineet, also. Okay, there we go. Thanks, Sneha, and thanks, Vineet. So Partha, I hope you are done. So now let me run the jar file. So I'm going to say Hadoop jar and the name of the jar file. What is the name of the jar file? This is the name of the jar file that I'm going to run. Let me right click and say copy and right click and say paste. Okay, so how will we run a jar file? We will say Hadoop jar and the name of the jar file. And I'm going to press enter, and it will give me the complete list of programs, what is there in that particular jar, guys. Okay, that's what I'm trying to show it to you. So let me scroll up a little bit. These are all the standard list of applications what will be there in the Hadoop examples.jar. And which is the applications that we are interested in, we are going to try. We are going to try with an example called as TerraGen. And what is TerraGen? It is a application which will generate some data for TerraSort. What is TerraSort? TerraSort is a benchmarking tool that we very typically use before the cluster is deployed for customer users. So in admin class, we'll be talking more about it, but then we will, I'll explain that to you. Kishore says, thank you, team, to both Sneha and Vineet. So let me go down to Google. I am going to search for something called as TerraGen, Hadoop TerraGen, so that you know what it is. So if you go down to Hadoop TerraGen, there is a link called as highly scalable system. Let me copy that link, and I'm going to put it into the questions window, and I'm going to put it inside my document also. Okay. So what is this link talking about? TerraSort is one of Hadoop's most widely used benchmarks. Hadoop distribution contains both the input generator and the sorting implementation. TerraGen is the one that generates the input, and TerraSort is one that conducts the sorting. What does TerraGen do? It generates random data that can be used as input for a running of TerraSort. Okay, so it is a program that is there by default available for you. Okay, let me go back to the PDF. We have seen the list of the examples. Let me go down to the next slide. So what are we doing over here? We are going to run the TerraGen example, and we are going to write it in the form of 1 million. Okay, so no, 0.1 million. So I'm going to have about 100,000 lines that I want to be generated, and this is the place where the output will be generated. So in any Mapreduce program, when you run a Hadoop jar, this is the standard way how you will run a jar. So let me explain that to you. Standard way of executing a jar file. You will say Hadoop jar, the name of the jar, dot jar, and then the name of the application. This is the way how you will run a jar file. So in this example, what am I doing? And then of course you will pass the parameters for the jar. So for running TerraGen, this is what I'll be doing. Hadoop jar. What is the name of the jar? Whatever is the Hadoop examples name.jar. The name of the application is TerraGen. The parameters will be, the first parameter will be the number of lines that I want. So let me take it into a next line so that it will be simple. The first parameter you will pass is the name of the application. The second parameter that you will pass is the number of lines you want to generate. number of lines to be generated. It will be generated as per randomly, as per the Java code. And third is, I will say slash, what is the name that has been given in the PDF? TerraGen output, TerraGen underscore output. This is going to be the HDFS folder where the data will be generated, guys. Okay? So this is how you will be executing a jar file, and that is what I'm going to run it and show it to you. Exactly, Mithun. The name of the application will contain the main. So let me run it and show it to you. So let me do a PWD, or I think I've already run it. So if I use my up arrow, you will see I have said Hadoop jar, the name of the jar file. First parameter would be, the parameter for the examples would be TerraGen, the name of the application. Then I am going to say the number of lines I want to generate, and I will say TerraGen underscore output. That will be in HDFS. And when I press enter, you are submitting your jar file. So see over here how it will automatically start with the Mapreduce program. See how it is connecting to the resource manager. See how it is generating the TerraSort using 2 splits, because the program internally is going to use 2 splits. See how it is submitting it to the job submitter. It has submitted an application. Okay. If you want to track this job, this is the application. So let me click on this link and it will automatically open up a browser for me, and the browser will be nothing but the, let me copy this link, controls, just one sec guys. Let me copy this link, right click. Just one sec friends, too many windows over here. Copy, let me go back to the browser and let me show this link to you. Come on, why is my click not working? There we go. I will say right click, paste, Control A, Control V, and I press enter, and you will see how the job would be running. It will give you the details of it. 8088 means nothing but the resource manager details. Let it get connected. While that is working, if I go down to the terminal window, you would see how it is running in a mode. You will see map 0%, reduce 0%, then it will come down to the map and reduce. It has completed, and it will give you some statistics. See here, these are all called as counters, and now my page also came up, the other page. See here, this is my Mapreduce application. This is what is my job ID, and you can see over here it is succeeded. So it will give you all the historical information about how the job actually ran, friends. This is how you will be running a TerraGen example, folks. Okay? So if you look at the PDF, you see over here also how it is generating the resource manager, how it is getting connected to that, and this is what is nothing but the different counters that has been generated. Okay? So this is, I'm running a program which is already there. I'm just executing that particular program. Cool. So now, where will this be stored? Let me go back. If I want to see the output, I will go down to my NameNode status. Okay, let me click on that link, and I will go down to browse my file system, because it's in HDFS, right? So I have to go down, and I should see something called as TerraGen underscore output. I will click on TerraGen underscore output, and you see over here it has created the part files which will have the results. You can click on the part file and you can see the results. Exactly. Good Asif, good Krishna, good Kirti. Okay, friends? So this is the way how you have executed the TerraGen example. Let me go back to my PDF. Another 5 minutes, we'll close it for today. So let's have a look at, to understand what is the Mapreduce output that we have. Okay, Vinith was asking why are the part files divided? It is divided because of the program. The program had said whatever might be the number, it will be divided into 2 part files. Okay. No, it has nothing to do with the block size. It is programmatically it was done, Vinith. Okay, friend? Cool. So if you look at the dump of the Mapreduce job, you will see the map output records would be passed on to something called as combine input record. So that means there is a mapper and there is something called as a combiner. The combiner will do some processing and there would be output of your combiner. Then the combiner output will go as your reducer input. And finally, your reducer details will be gone as a reducer output. So this is the way how the whole thing would work, friend. Okay. Hey, Arvind was saying the part file is divided into two if there is no intermediate work. No, Arvind, no, please don't jump to conclusions, friend. No, in this program, it has got nothing to do with intermediate files. The program programmatically had said whatever might be the number of lines, Arvind, it will create two files. That's it. So in the Java program, you will have to see what it is. Sneha said, I don't know what are the difference between combiner and reducer. Don't worry, Sneha, we haven't covered that also. Okay, so we will just have it in our example. We have just seen that, friend. Okay. Hey, Arvind was saying, I heard it in a pre-recorded session. No, I think it is wrong then, Arvind. I'm sorry to differ with another instructor, but the part files have got nothing to do with the intermediate process. The reason why you're having it as 2 is because the Java code has mentioned it as 2, my dear friend. Okay? Hey, good, Arvind. No problem, friend. Thank you. Hey, let me go back to something else. Sneha was saying combiner is nothing but reducer. No, Sneha, we haven't seen it. Don't worry. Kirti was saying, if one file succeeds, if the job or the task fails, do we see the fail or the error, or will there be any part file? If anything fails, you will only see error. You won't see success, Kirti. Hey, Annie is back again with some of our questions. So, where is the output of the Mapreduce job stored, guys? We just saw it right now, right? So it's a no-brainer. So where is it stored? It is stored in HDFS. Yes, true? Exactly, friend. So you would see that. Yeah, good, Asif. You have understood that, but then we will have a look at it as we go ahead, Asif. No worries. So the output of Mapreduce is stored in HDFS. It will be stored in the form of different part files. Okay. The part files are created on the basis of the block size. No, that is not exactly correct. Okay, the part files are based on the applications. Okay, it is not based on the size. See, they have changed this. Earlier, this line was not there. So I don't know why they have kept it as it is. So, hey, another question. So to run the Mapreduce, the data should be present in HDFS. True or false, guys? So the answer is true. Both input and output has to be in HDFS. So let me go down to the next slide. Okay, just one sec. There we go. So true, in order to process the data in parallel, it is necessary that it is present in HDFS so that Mapreduce works on chunks of data in parallel. So now there are a lot of different data loading techniques that we have. When I say data loading, you will talk about how the data is going to be put into the cluster and what is the way how you will be able to analyze the data that is already there in the cluster. So if you look at the data loading techniques, there is a technique called as Flume. So using Flume, you will be able to analyze the data that is there in the cluster. And I have already have shared in the class documents, the copy link that I have shared with you, Edureka link. There are some document on how to play around with Flume. We will be looking at it in our last module. Module number 10 is when we'll be looking at Flume. There is also Scoop. We'll be looking at Scoop. So Flume is import-export of semi-structured data, like your Twitter feeds. Scoop is import-export of your structured data. And for your normal files, etc., like images and directories, etc., you will have to use the Hadoop copy commands. I'm sure if you have gone through the HDFS commands and the Linux commands, you would know how a file gets copied onto the cluster. Once the data is in HDFS, how will I go ahead with the analysis? I will either be using Mapreduce, or I'll be using Pig, or I'll be using HIVE. So what to use is dependent upon the type of the data. So now this slide talks about the 3 techniques of loading the data and the different analysis. Let me tell you what are the industry best practices. So if you look at day 4, if you're having unstructured data, the only way of analysis, I'm talking about the types of data and the analysis techniques used. So if you're talking about unstructured data, you will have to use Mapreduce. There is no other way other than Mapreduce. So if you go down, I hope all of you know about MATLAB. MATLAB also is using Mapreduce. So search for MATLAB, which is an image processing software, and Mapreduce. There we go. So if you click on this link, MathWorks, you will see how Mapreduce is used within MATLAB. A very strong suggestion is for you to try it out. There we go. Let me just copy this, Control X, I'll put it up. Then for, again, another framework for image processing is HIVE. That stands for Hadoop Image Processing Interface. So it's a library for Apache Hadoop programming that provides an API for performing image processing in a distributed manner. I don't know what this guy is doing over here for HIVE. Okay, very funny. Okay, so it's not actually a hippie, it is a library. So this is what happens when a software tries to bring together things together. And there's no way that this image should have been associated with this wordings. If a human being has seen it, he would have definitely known that this is not correct, right? Cool. Hey, MATLAB is for image processing, signal processing, etc. That's correct. Cool. So these are the two APIs that you will have to look at. So let me copy that link also for you so that you will understand this is the way how your images are going to be done. So you need to play around with it. This is for somebody who had asked me how to go ahead with unstructured data. Let me copy this over here so it will be more relevant. We are talking about unstructured data. Then you will have semi-structured data. So if you talk about semi-structured data, you would typically use your PIG, which is a scripting language, and of course you can use your Mapreduce also for that. But if you are having your structured data, structured, T-U-R-E-D, structured data, you will first use your HIVE. Then of course you can use your PIG and you can use your Mapreduce. So this is the different techniques for analysis vis-a-vis the type of data that we are having. This is as a thumb rule that we use in the industry. Let's continue now. So let me go down to the next slide. So these are the various Hadoop copy commands, which is already present in the HDFS commands exercise in your module 1. So you will say Hadoop DFS minus put. Minus put is a way how you can move the files from your local file system to a destination file system. Of course, it can read from the standard in also, and it will put this particular file into HDFS at this particular location. You can also use minus copy from local. The only difference is it is restricted to the local file reference. You cannot read from a standard in. And then you will have distributed copy, which is for moving data between clusters if you want to do any backup or a recovery. So these are the standard Hadoop commands, copy commands that we have. So let's continue. So this is about Hadoop copy commands. Now, we will be talking more about Scoop as we go ahead in our last module. So if you are going to use Scoop, what is Scoop? Scoop is a tool to move data from any structured data source to your HDFS. So let me give an example. Like I had mentioned last week, I was with Amdocs, and this week I'm going to SAS in Pune. So tomorrow, for the next 4 days, I'll be there in SAS in the India Development Center at Magarpatta, Pune. So they would see that why are SAS using this? Because SAS is also having its own connectors. SAS also wants to know how the whole Hadoop environment works. So this is the thing about the 17th or the 18th batch that I'm doing it in SAS for the different people. Every batch would have about 24 participants. So what do? is even the people who are SAS certified, they will also have to go through the same course like what you are going through. Of course, it's my personalized course. It is not through EduReka. So what they do is they will go through HDFS, they will do the installation, they will do the settings, etc. So the important thing is how are they using Scoop? So if you have got the data, typically your transactional data would be there in your SQL layer, right? So if I want to move the transactional data to my HDFS, I have to do it because then only I can do the ETL in the Hadoop layer in the data lake. So how do I move that data? You will have to use Scoop for that. Last week I was there with Amdocs. So AT&T, Amdocs does the back office for AT&T. So they have got a data lake where all the transactional data from Oracle data stores and from Teradata, that's a data warehousing tool, gets moved into your Hadoop layer, that's the data lake using Scoop. So you can either import individual tables or else you can import the whole database. It automatically generates a Java class. More details on this will come up in your module number 10. And this is just to give you an example of what might be a sample command of your Scoop import. Import means bringing it into HDFS. Don't think of import from the perspective of your RDBMS. So this is the way how you can give your, this is the way how you can give your link to your JDBC, ODBC layer with the username, password, and the table that you want. Then this is the way how you can give what is going to be the custom output directory in your Scoop. So the way how you specify a custom output directory is using target dir or using warehouse directory. So if you say target directory, it is going to be the location where you're going to dump your data, and warehouse directory is another option for choosing it to a data warehouse. So you can even point it to import data from a RDBMS and then move it on to Teradata. So both import and export is possible. So this is just a little bit additional stuff that they have. So you can use your target dir parameter to specify the output directory name where Scoop would import the table data to. So you can see over here it is going to be target directory Scoop out. In case if you want all the Scoop imported data to be imported and kept it in one common directory in HDFS, you can use the -warehouse dir parameter. So please note, Scoop will always create a directory with the same name as the imported table inside your home directory. So different options are available for you. If you can specify the output directory using target dir, or else you can specify the output directory using warehouse dir. So more example of the target dir will be in the module number 5, wherein you're going to do the hands-on. So this is just to give you an example, importing only a subset of data. So in case if you wanted to import the whole table, okay, you can definitely do that. But in case if you wanted to import only a subset of a table, you can do that with the help of a where clause. So if you just want to load only a part of a table, you do it using the where clause friend. Okay? So in case if you are importing only new data, this is also a very important point to note, because every day a new data would keep on coming. So if you have a database table with a integer primary key, and if you're only appending new rows and you need to periodically sync the table state to Hadoop for further processing, so you can easily do that using this query. So there will be Scoop import, connect username, password, and table are there. Incremental append is what is important. The slash you're having is because I'm writing it in a new line, okay? Incremental append is the way how you will be able to do the incremental transfers. So incremental import also requires 2 additional parameters. The last check column indicates a column name that should be checked for the newly appended data, and the last value contains the last value that was already imported into Hadoop. So that is the way how you can incrementally append the value. So in this example, anything greater than 1 will be appended. But the only downside of this thing is that you should know the value of your last imported row so that Scoop can start off where it ended. But this is what we do in our real environment. Okay? So then Now let's look at the second layer that we are having, that is called as Flume. You are going to use Scoop to only move that particular file. So you saw what is Scoop. It is simply an import-export tool. Now you are having Flume. So what is Flume? It's an import-export of semi-structured data. Why is Flume there? Because it's distributed and efficient. It collects data from the various sources and aggregates it into one place. So you will see later on that there are three important concepts what a Flume has. There is something called as a source, there is something called as a channel, and there is something called as a sink. We will talk about it as we go ahead. So it is different from the other data loading techniques that it can pull data and put it into different sinks at the same time. So anytime you are having streaming data, Flume is a very good way of working with it. So you see over here what all are the Flume components. One, you talk about an event. What is an event? Any unit of data that you want to put it into your HDFS. You will have agents. So it's a JVM process that helps events to flow through from the source to the sink. So you will have an agent that is there at the source side. A source is the place where the external sources like web servers delivers its data. Sink is always HDFS where the final data is going to be dumped. You also have got something called as interceptors, which is primarily filters, so that you only take the data that is relevant for you so that you can put it into a sink. Channel is a link between the source and the sink from where the data gets transferred. There are multiple channels, out of which only a few can be selected using a channel selector for data transfer. And finally, once the data is there in the sink, you would have to use something who will drain out the data from the sink. That is what is your sink processors. It's typically used to maintain the failover and load balancing amongst the multiple sinks what you're having. Okay, so this is what is a fantastic diagram of what is Flume. So you can see here there are multiple web servers. You will have multiple sources. You will have interceptors over here so that you can filter what you want. There would be a channel selector which will identify what channel that I need. Then events go through multiple channels. It will go down to the sink processor, and then finally it will go down to whichever different cluster that you want so that you can do your processing. So this is the way how a actual environment would look like. So Flume is primarily for semi-structured data. Scoop is primarily for structured data. Okay. So you can see over here, we will see an example of Flume streaming, Scoop input command. All these things are there in the document over here, guys. So if you look over here, there is a document. So Flume setup, this is something that you'll have to look at. And for Scoop also, there is a document that is available which you can play around with. So now, having understood the theory part of it, Annie is back with the questions. What do you think the answer is, guys? So if you talk about any semi-structured data, it is of course going to be Flume. So this is primarily Flume. So this is a no-brainer. Good. So this is another simple use case. Let me know what should I do here. I want to join data from two sources. One source of data is collected from a big database of call records already available in HDFS. Other source of data is a database table. So we know that for sure. So what do? Will I use a HIVE query? No, HIVE is used for analysis. Will I use a pick script? No, that is also used for analysis. So of course the answer is Scoop input. So the right answer is your Scoop input. So now these are the assignments that you are going to have. So please go through the Eureka VM and explore it, checking the working condition of the Hadoop ecosystem so you can see how you can play around with. So these are the additional reading stuff. So please really go down to these documents so that you will understand what all are the reading stuff that is needed. So this will help you out a lot in understanding how to do the setup. How do I go ahead and install Hadoop in the Amazon Web Services and in your EC2? How do I select a hardware for Hadoop? Primarily that is for admin, but still we have kept it over here so that people can have a look at it. So there are some further readings that you'll have to do. I hope all of you have done the Mapreduce part of it, because that's what we're going to start today. Mapreduce job execution, how to add nodes in a cluster, a little bit more about secondary name node. Everything is detailed over here. So please go through these recordings. What is the pre-work? So I hope all of you have gone through the Java Essentials, and there is a couple of interview questions in setting up Hadoop. Have a look at those also. So what is important, guys, this week for all of you is to look at the Hadoop definitive guide and look at the chapter number 1, 2, 3. Also go through all the links that we have given over here. The more hard work that you do, the more work that you do, it will be comfortable for you. So what are we going to do now? So the next two modules are completely on Mapreduce. So we will talk about what is Mapreduce, what are the use case for it, what is the difference between the traditional way of processing and the Mapreduce way of processing, what is the hands-on. Yesterday some people are asking about container and application master, etc. All those things are processing part of it, right? So we will be talking more about that in our module 3 that we'll start now. How does a complete end-to-end analysis look like, and some of the Mapreduce concepts. So with that, we are done with our module 2, guys.